Meet Pam, Richard, Jane, and Sue, a group of analytical scientists. On a day-to-day basis, they perform analytical testing on samples, such as agrochemical, pharmaceutical, food safety, and academic research. Their job is not only to determine what is in their samples, but also how much of an analyte is present. They all face similar challenges in their labs, which can be overcome with different mass spectrometry solutions. For instance, one of the biggest challenges Pam faces when developing trace-level quantitative methods in agrochemical development is the need to analyze enantiomers that may be present in the active ingredient. When using a chiral reverse phase UPLC, Pam is not able to separate 2-triazole fungicide enantiomers. However, by using supercritical fluid chromatography, SFC, Pam can resolve the enantiomeric peaks with high chromatographic efficiency. This helps her get accurate and precise final residue levels for each isomer, and more accurate risk assessment of the crop protection product. At the pharmaceutical lab, Sue struggles to conduct her analysis when the instrument doesn't tolerate dirty samples, such as plasma or urine. Having to perform maintenance takes away her valuable time. She would greatly benefit from a mass spectrometer that utilizes an off-axis ion guide. This removes neutral molecules and gas load, providing robust high-sensitivity analysis, leaving Sue with more time to review her results. Within Jane's food safety testing lab, method development can be a challenging exercise. Whether building the method from scratch or extending the method's scope in terms of analytes or food types, she needs to be sure she can detect the analytes of interest in a variety of complex food matrices and report all results with confidence. By acquiring a full scan, simultaneously with her optimized MRMs, Jane can understand the complexity of her MS background. This additional information helps Jane to decide if changes are needed to sample preparation or the chromatographic gradient to minimize matrix effects and provide a more robust analytical method, accurately quantifying analytes at trace levels. As for Richard, he's been at the university lab conducting research on steroids. However, there are some compounds that don't ionize optimally with ESI. For this, he turns to APCI or APPI. Each method has its own advantages and disadvantages, but it is time-consuming to be switching between the different sources. Richard needs the flexibility of an MS system that will allow him to use all methods. Rather than ESI, Richard could also use the Unispray source, which allows him to analyze a wider range of compounds in the same injection and achieve the desired LOQs. These scientists require the appropriate methodologies along with fully integrated LC-MS systems for robust, accurate quantitative measurements. Whether it's separating analytes from complex matrices, detecting unknown components, or having different ionization options and configurations from which to choose.